Good day and welcome to this Focus On segment. I'm David Rademan. I'm here reporting from the 8th CSIR Biennial Conference in Pretoria, standing specifically at the Exhibition Centre. As you can see right behind me, there's a lot of excitement happening on new technology and the new innovations on display. Let's take a look at a few of these.
This is our 8th Biennial Conference. So we have this conference every second year from 2008. And the main reason for this is really to expose some of our activities within the organization to the outside world, because CSIR, as you know, is meant to improve the lives of ordinary South Africans, but also the world at large. Some of our contributions are not only confined to South Africa, they also are of use globally, because we are in the science space, which has no boundaries. So we have to be visible at all times. And the walls that we operate within are not sufficient for that, and the work on its own cannot achieve that. So occasions of this kind, where we have a conference, bring in people from outside, but they also in a way give us a chance to go out to the people, because through this we learn from people what is missing out there that perhaps we are not doing, but people also learn from us what we are capable of offering on various fronts. So what we've learned from all these years is that through this conference, we formed a number of partnerships, because, as I say, we get a chance to be exposed to other people as to what we can offer. We formed a number of partnerships, and these partnerships for us are very, very crucial as CSIR. CSIR, actually, according to its mandate, is supposed to do directed research that is meant to improve or enforce industrial development. And we cannot do industrial development if we are not working closely with industry. And you will see that most of the people that we have here actually come from industry. And that's exactly what we wanted to achieve.
Explain this technology to me briefly.
Okay, so the technology is called television wide space. It's a form of dynamic spectrum access. It allows a network operator to access radio wave in the spectrum band, particularly in the television band, to access the unused part of the spectrum to provide broadband services in rural and township areas.
Is it currently operational, and where is it operating?
Yes, the technology is operational in South Africa. It has been deployed in a number of provinces by small and medium enterprises under our support. It has been deployed by the industry associations like the Wireless Association Providers of South Africa. We have deployed it in areas like Limpopo and KZN.
This technology is, like you said, it's to access the most rural areas. How exactly are you tapping into that spectrum?
Okay, so of course the pattern of how the networks are being rolled out in the past 50 years is that urban affluent areas, they get better services from the big telcos because of the issue of return of investment, whereby rural and hard to reach areas, they don't get the best deal from the big operators. This is because those areas have got low population with low income, who can't afford services like 4G or 5G. So this technology comes in to support those areas because it's affordable, it's low cost, and it is long range. So with a minimum investment, you can cover a bigger area, even hard to reach areas, and provide the services which are at the same standard as the services people in affluent areas can afford.
Part of this technology is to allow rural areas access to internet for educational purposes. Can you expand on that? That education and agriculture, can you expand on that a little bit?
Yes, this technology can allow very remote rural schools to be connected to the information superhighway, and thereby they can start utilizing technology of the fourth industrial revolution, like e-education and so forth. The technology can also be used to support the smart agriculture and Internet of Things to improve the productivity in farming.
Expand on that a little bit. What do you mean it can help improve productivity in farming?
Okay, so we know that if one have to scale out in farming, you need some equipment and a lot of manpower to support your project. But with IoT and connectivity like that is provided by this technology, you can now use sensors that are embedded in equipment, and they can be remotely controlled and thereby improve the productivity.
Quickly explain this technology to me.
Basically, it's an ultrasound device that measures the blood flow in the common carotid artery, and from that we can develop the prognosis of a patient's cardiovascular system.
And the whole concept or notion of this device is to take it to the most rural clinics, rural parts to do screenings there, right?
Yes, this is based for primary healthcare in clinical environments. It's a mobile device and can work wirelessly, can work with cell phones, smartphones, laptops, tablets, and obviously through internet you can save the data and use it for future diagnosis.
What spurred this innovation on?
It comes from a previous development we did called Ambiflow. It's the nature of our work to work in ultrasound and sound. So we had a request to investigate in medical applications in ultrasound.
And this technology was designed and innovated in the CSIR hub?
Yes, it's basically we've developed it as a low-cost medical device. We've gone through the certifications and requirements, and hopefully we'll soon have it in production.
And all locally manufactured?
Locally manufactured and developed as far as possible. Obviously some of the electronic devices are imported, but the manufacture is locally done. The housing is grown locally, and we use as many local manufacturers as we can for all the components.
And another part of this technology is any patient, when they move around or they travel around, their primary health practitioner can access the database from anywhere, correct?
Yes, because the data is stored electronically, it is available to be stored in a cloud, and patient records can therefore be equally stored and accessed wherever they're needed.
Speak to me about this technology. What am I looking at?
So basically you're looking at the optical coherence tomography latent fingerprint acquisition device. Basically this device, it uses the OCT system where it actually captures images using laser light or breadboard diode.
Now, what inspired you to create this technology?
So the motivation came on the fact that at crime scenes, when the forensic actually investigating the crime scenes, they normally use conventional or traditional methods where they powder the fingerprint that's left at materials, and then they normally use either tape or they take a picture of that image. So already when they powder the fingerprint, it's already damaging that fingerprint. In order for them to actually see the fingerprint, it actually damages the fingerprint, whereas they can't actually do further investigation on the fingerprint left on the material. So with this system, what it does is you can actually capture the fingerprint without actually dusting any powder on it, which means you can actually still have further investigation on that fingerprint that's left on the metal or on the material when you already have the image as well, when you capture the image as well.
How long have you been researching and designing this concept?
This research actually started, I think, 2006, because this is actually our second product for a different application. But the system itself, we've been researching it since 2006, and then so far, for this application, we started around 2018 to actually develop everything, have a custom-made system specifically for latent fingerprints.
Now, looking at it, it is a bit of a bulky machine. Are you looking at at reducing it in size?
Yeah, so currently we are actually looking at reducing it in size because the laser source is the one that's a bit big. So we're researching on how we can then minimize that to have a portable MVP.
Estimately, how much funding do you think is required in this research?
For this research to be continued, it could be over $1 million, estimating over $1 million. Just an estimation, not that's the proper price, yes.
How do we bring potential investors to the exhibitors to form these kind of partnerships you're talking about in getting these innovation manufactured so we can put it in a commercial market?
Yeah, there are a number of avenues for that. So either we deploy our technologies for competitive advantage. So we work with established industries where we use our technologies to improve their competence, but we also use our IP to generate new companies, or I would say the small medium enterprises. So there are two avenues here. We can either work with established entities, the conglomerates that are well established, so that we improve their competitive advantage, and there are quite a few of those that we work with, or we can form new industries, and we've got the facilities here on campus. We've got a few campuses at the CSIR. There is this campus here in Pretoria. We have a campus down in Durban and another one in Cape Town. And in all these facilities, we do have the wherewithal to actually support small, medium enterprises.
Where to from here?
We have to do this a bit more, because we have seen the fruits of doing something like this in the past. Even at the time when it was difficult to do so in 2020, we still maintained to work with a number of industrial partners who came on board, despite the fact that we had not had this physical presence. So the best way of doing it is to, through this, work closely with the people in the far-flung areas, for example, who do not have the facilities to take their know-how to where it matters most, and that is commercialization, where people can actually benefit directly from this. And as I say, we've got facilities that allow people to come on board with ideas only. And our scientists work with these ideas using our laboratories here to bring these ideas to life. And from then on, the steps are very, very straightforward.
And that wraps up today's Focus on segment at the 8th Biennial Conference at CSIR in Pretoria. I'm David Raudemeyer. Until next time, goodbye.